Welcome everyone to another video in our FE Civil Preparation course. This video is going to be our first video in Part D, which is the last part in the Mechanics of Materials for FE Civil exam. In this part, we are going to cover the principles of combined stresses and strains as well as Mohr circle. In this video, we are going to cover our first topic in this chapter, which is principal stresses. In our last chapter, we were focusing on studying stresses in single direction each time, such as normal stress or shear stress. But in reality, this is not always the case. Let's take this beam as an example. Here we have a beam under uniaxial tension force. Hence, if we took a stress element in this direction as shown, it is going to be under normal tensile stress only. But let's assume that we have an inclined connection between the beam in this direction, and we need to design the welding connection as we can see here. Is it going to be also under normal stress only? Of course not. In this case, the normal tensile force is going to have a component forces on these directions, which means that in this case, the stress element in that direction is going to have both normal and shear stresses components. And we will end up with this stress element, with both normal and shear stress in both directions. In this video, we are going to learn the relation between normal and shear stresses. In this video here, we are going to monitor the change in normal and shear stresses as we rotate a stress element. Let's assume that we have this stress element here that is under positive normal stress of 20 in x direction, positive normal stress of 7 in y direction, and positive shear stress of 10. We consider the normal stress to be positive because it is tension in both directions, and the shear is considered to be positive when it is trying to deflect the stress element to the right, as we can see here. You can easily remember that by looking at the force above the stress element. If it is going to the right, it means it is positive shear, and if it is going to the left, it means it is negative shear. Okay, so now let's start rotating the stress element and monitor the change in normal and shear stresses while we are rotating the element. We can see now that after rotating the stress element 180 degrees, both normal and shear stress returned to their original state, which actually makes sense. It is very important to remember that rotating the element is not affecting the overall normal and shear stress on the body. However, we are just rotating the axis of an element inside the body to study the normal and shear stress at these particular locations. We can also notice that both maximum and minimum normal stresses are separated by 90 degrees rotation angle between both of them, which means that if we rotated an element to have the maximum normal stress in x direction, it will always be corresponding to the minimum normal stress in y direction. We can also notice that both maximum and minimum normal stresses occur at the case of zero shear stress. Those maximum and minimum normal stresses values are what we call the principal stresses of an element. So now, for any element under the effect of normal and shear stress, we can calculate the value of the principal stresses using following formula: sigma A and sigma B, which are the maximum and minimum normal stresses, equal sigma x plus sigma y over 2 plus or minus root sigma x minus sigma y over 2 all squared plus tau xy squared. So now, let's have an example on this. So let's check this example here. We have this stress element. It's under tension force in the x direction of 50 megapascal and compression force in y direction of 10 megapascal, and we have shear of 40 megapascal. To know if the shear force is positive or negative, the easiest way is to look at the direction of the force above the stress element. Is it going to the right? This means it is positive. If it is going to the left, it means it is negative shear. And we want to calculate the principal stresses. So we will use the equation which we have just learned, sigma A and sigma B equals sigma x plus sigma y all over 2 plus or minus we have sigma x minus sigma y over 2 all squared plus tau xy squared. Solving for this equation, we have the sigma x of 50, and it is positive because it is tension, plus sigma y. Sigma y is 10 megapascal, but it is compression, so it means it is a negative sign, so minus 10 over 2 plus or minus root sigma x of 50 minus the minus 10, so it is positive 10 all over 2 and all squared, and the tau, which is the shear stress, it's or the shear force here, and tau, which is the shear stress, we have 40 megapascal, and as we said, we will look at the force above the stress element, and it is going to the right, so it means it is positive, so it will be plus 40 power 2. Solving for this equation, we get 20 plus or minus 50, so we get 70 and minus 30 megapascal. So this is the answer. So this is it for our video today. Thank you.